In this lesson, we're investigating half reactions. Our lesson objectives: identify if a reaction is oxidation or reduction, and write half reactions for oxidation and reduction. Our redox reactions will have an oxidation half reaction and then a reduction half reaction. So let's see what that looks like. Here's a redox reaction. The first thing we do is we assign our oxidation numbers, as we have done. Uncombined elements are 0, so are diatomics. Oxygen is going to be a -2 and magnesium is going to be a +2. And so what we see, I'm going to connect here with brackets, is the oxidation piece. This is my loss of electrons. Magnesium go from 0 to +2. And then the reduction piece, which is oxygen going from 0 to -2. And so if we pull these out, our oxidation half reaction, since it's half of this full redox reaction, is Mg0 to Mg+2, which I've written here. And Leo tells me that's a loss of electrons to go from 0 to +2 because I'm losing 2 negative charges. And so we have a loss of electrons being shown on the right-hand side of our reaction. And then for the reduction, that's this bracket here. That's the oxygen going from 0 to -2, which I've written down here for you. And then, because it's reduction, it's a gain of electrons to go from 0 to -2. We're gaining 2 negative charges. So we're gaining 2 electrons, and that gain of electrons is shown on the left-hand side of the reaction. So a half reaction shows either the oxidation piece or the reduction piece of this full redox equation. And it's going to include those electrons being lost or gained. And so let's look at these things individually. So the half reaction for reduction shows an atom or ion gaining 1 or more electrons. That's my GER in my Leo GER. And so if we look at this example here, Fe+3 to go to Fe0, since we're gaining electrons, the gain of electrons is going to be shown on the left-hand side of the arrow, or the left-hand side of the reaction. This is called the reactant side. And so for reduction half reactions, we can identify them by the fact that they have electrons on the left-hand side because they're gaining electrons, and gaining electrons is reduction. The oxidation half reaction shows the atom or ion losing electrons. That's our Leo from our Leo GER. Loss of electrons is oxidation, and that's being shown by the electrons on the right-hand side of the arrow. So the right-hand side of this reaction, we call this the product side. And so in this case, Mg0 goes to Mg+2 by losing those 2 electrons. So recapping, reduction half reactions, the gain of electrons is shown by electrons on the left-hand side of the reaction. And oxidation half reactions, the electrons are shown on the right-hand side, showing a loss of electrons. So let's check your understanding. Can you identify if a half reaction is oxidation or reduction? And now we're going to balance charge in these half reactions. And so I'm going to show you an example first. And if you're given a half reaction such as the one here, and I want to balance the charge, I have to put in the electrons. In order to do that, I have to first figure out, is this showing oxidation or reduction? And so first thing I do is I'm going to fill in any missing oxidation numbers. So this is an uncombined element. That's going to be 0. We already have the charge here, +1. And so we look at it and say, okay, it's going from 0 to +1. That oxidation number is increasing. It's getting more positive. How is that possible? Well, we're going to be losing negative charges, losing electrons. And using our Leo GER, loss of electrons is going to be oxidation. So now I know it's oxidation. A loss of electrons is going to be shown by having electrons on the right-hand side. So they're going to be on this side of the reaction. But now how many electrons do I put in? Well, look at your oxidation numbers. They go from 0 to +1. I've lost 1 negative charge. That means I lost 1 electron. And then you can verify they did this correctly, and you place these electrons on the right side, or the appropriate side, I should say, by looking at the total charge. The total charge on both sides should be equal. So for the reactant side, the left side, we have 0, and on the right side, the product side, we have +1, and we have a -1 charge from the 1 electron. And so +1 and -1 also equals 0. So I have 0 on the left, 0 on the right. We have now balanced our charge for our half reaction, and this is a balanced oxidation half reaction because our electrons are on the right. It's a loss of electrons. Okay, let's try one together. We do the same thing. First, determine if this is oxidation or reduction, then add in the electrons to balance the charge, and then just double check and make sure that it is balanced. So we want to figure out, is this oxidation or reduction? So is this an oxidation or reduction half reaction? So what we do is you look and see we have +2 here and 0. So our oxidation number is decreasing or going down or reducing. So that means we're adding negative charges to this +2. And so adding negative charges, that means we're adding electrons. That's our GER from Leo GER. So a gain of electrons is reduction, and we show reduction, that gain, by putting electrons on the left-hand side. How many electrons? +2 to 0, we're going to add 2 negative charges, 2 electrons. And we can verify that we did this correctly by looking at the total charge. So on the left-hand side, we have +2, and we have 2 negative charges from the electrons. So +2 and -2 is going to equal 0 for the reactant side. And we have 0 on the product side. So 0 on both sides. We have a balanced half reaction. In this case, it's a balanced reduction half reaction. Okay, now you try one on your own. Okay, so the first thing you do is going to add in the missing oxidation number for our uncombined element of 0. We're going to figure out, is it oxidation or reduction? So we see it goes from 0 to +2. It's getting more positive. So we're losing negative charges. It's a loss of electrons. Loss of electrons is oxidation. So now we should know that electrons are going to be given off and then be shown on the right-hand side of our reaction. And how many electrons we're going to show? Well, 0 to +2, we're losing 2 negative charges. We're losing 2 electrons, which I have placed here. And again, always double check, make sure the charges are equal on both sides. So we have 0 on the left side, and on the right side we have +2 and -2, which equals 0. So 0 on both sides. This is a balanced oxidation half reaction. Let's check your understanding. Can you write half reactions for oxidation and reduction? At this point, you should be able to identify if a half reaction is oxidation or reduction, and write half reactions for oxidation and reduction reactions.